11.1, we're going to be finding the limits of trig functions. So our trig functions are sine, cosine, tangent, and their reciprocals, cosecant, secant, cotangent. When we're finding the limit of our trig functions, so the limit as x approaches c of sine of x, we can just plug in c, our value for c, into the x, and that would be our limit. So our limit would be sine of c. Same thing with tangent, cosine, cotangent, all of them. We run into an issue when it gives us a value that's undefined, because just because our value is undefined doesn't mean that the limit is undefined. So we have two special trig limits. These you have to memorize. So the limit as x approaches 0 of sine of x over x is equal to 1. And the limit as x approaches 0 of 1 minus cosine of x over x would equal 0. Now we could, if we had a calculator, we could find these out. We could work them out mathematically and show the work of how or why these are, but the easiest thing would be just to memorize them. These are two special trig limits that you got to memorize. One way that you could work it out if you ever forget is we could make a little table. So let's say I was finding the limit as x approaches 0. We'd want to plug in numbers above 0 and below 0. So we could plug in like 0.1 or 0.01, and we could plug in negative 0.1 or negative 0.9 or something close to it, and you'll see that our values approach 1. So even though it does not exist at 0, because putting 0 in the denominator, it does not exist, our values would approach 1, so that's why our limit is 1. So with example 1, with a lot of our limit questions, when we plug in our x value, or c, so we plug in 0 here, it's going to help to have the unit circle with you to evaluate what the tangent of 0 is and the sine of 0. So a couple things that we need to remember is the sine of x tells us that we have to look at the x or the y values. Sine, we look at the y values on the unit circle. Cosine tells us that we look at the x values. And tangent tells us that we look at the y over x values. So then our reciprocal functions would be the reciprocal of this. Cosecant would be 1 over y. Secant would be 1 over x. And then cotangent would be x over y. So these are the values on the unit circle that we would look at. So if I just plugged 0 in right away, I have the tangent of 0 over the sine of 0. Well, the tangent of 0, tangent we said is y over x, so we're looking at 0 here. Y over x would be 0 over 1, which would just be 0. Sine of 0 would be the y value, so that would be 0. But what happens when I have 0 in my denominator? It's undefined. So we can't just plug in 0 right away. We have to do some simplifying first. So we can't just plug in 0. We got to simplify, because when we plug in 0, it gives us undefined. So we're going to use our trig identities to help us simplify. I can simplify tangent to be sine over cosine over sine. What do I do when I have a fraction in a fraction? Keep, change, flip. We're going to keep the top, change to multiplication, flip the bottom. Sine of x is a whole number right now, so we could make it over 1. And then when we flip it, it's 1 over sine of x. Thank you. The signs cancel out because I've got a sign on top and a sign on the bottom. So I'm just left with 1 over cosine of x. You can change this to be secant if you want, or just leave it like this. If I were to plug in 0 here, let's see if it works. We've got 1 over cosine of 0. What's the cosine of 0 looking at our unit circle? So we go to 0 on our radians. Cosine tells us we look at the x value, so what's cosine of 0? 1. Perfect. So this would simplify to 1 over 1. So our limit would just be 1. Let's look at example 2. I'm going to copy and paste my unit circle in here again. So for number 2, first thing we want to try to do is just plug in our c. Plug in what x approaches. So here we have pi over 2 times sine of pi over 2. Let's find what sine of pi over 2 is. So going to my unit circle, I want to find pi over 2 radians, which is up here. Sine tells us we look at the x value or the y value? The y value. So what's our y value here? 1. So we have pi over 2 times 1, which would just give us pi over 2. So that would be our limit. First thing you always want to do is try substitution. Plug in what x approaches, plug in your c value, see if it works out. If you don't have a fraction for something like this one, or if you don't end up with 0 in your denominator, you don't have something undefined, then it's probably going to work by just plugging it in. B is not going to work by just plugging it in because we're going to end up with 0 in our denominator. But this looks super similar to one of our rules that we have to memorize. We know that the limit as x approaches 0 of the sine of x over x is equal to what? Go back to the third slide from the notes. It equals 1. This is something that you guys need to know. So B looks super close to that. Now we can just look at this and I'll show you the shortcut way of how we can find the difference between how we can go from this to this, what our answer for our limit would be. But I'll also show you the worked out way too, the long way. So here, the sine of 5x over x. What's our coefficient for x on the bottom? 1. So our limit, instead of just being 1, it would be 5 over 1, which would be 5. Now this is the shortcut way, but I'll show you why this works mathematically, the worked out way. If we have the limit as x approaches 0 of sine of 5x over x. So we could show our work this way. So ignoring that we already know the answer, we can multiply the top and the bottom of our fraction here by 5. Up top, I'm just going to leave this as sine of 5x times 5. I'm going to leave that 5 kind of over on the side there. Over on the bottom, I'm going to combine these two together. So now we have 5x. Now sine of 5x over 5x, this equals 1, or the limit, because it's still the limit as x approaches 0. The limit as x approaches 0 of sine of 5x over 5x is 1. But now we still have that times 5 with it. And 1 times 5 would be 5. So if you ever had to show your work for a question like this, this would kind of be how you show your work. You want these two to be the same. when they're the same, your limit as the sine of whatever over the same thing, it's going to equal 1. All right, let's do C. C again looks super similar to the formula that we know. It looks super similar to the limit as x approaches 0 of sine of x over x, which we know this equals 1. So we want to kind of change the way that sine squared of 5x over x squared looks. We're going to do some rearranging of our function here to get it to look like this, so we can use the fact that the limit as x approaches 0 of sine of x over x equals 1. So because they're both squared, I could actually split them up. I could say the sine of 5x over x times the sine of 5x over x. If I were to multiply these together, it would give me sine squared of 5x over x squared. We're still taking the limit of both of these. Which we just did the limit of one of these. We said the limit of sine of 5x over x equals 5. So if we're multiplying it by another 5, it'd be 5 times 5. But let's work it out. You could either do it the shortcut way, knowing that here our coefficient in front of our denominator is 1. So our limit would be 5 for our first fraction, times same thing with the other one. We've got 5 over 1. And 5 times 5 would be 25. So our limit as x approaches 0 here is 25. So always the first thing we want to try to do is see if substitution will work. Because if substitution works, you're just going to look at your unit circle, find your trig functions, the values of them, and just plug it in. But looking at A, is substitution going to work? No, because it'll give us 0 in the denominator. So we got to do some simplifying here first. I can split this one up into the sine of x over 5x times the cosine of x. So now we can find the limit of each one of these separately. What do you think the limit of the sine of x over 5x is going to be? 1/5, awesome. Our coefficient in front of the x would be 1 up top, so it'd be 1 over 5. So this would give us 1/5. Now let's try with cosine what we get if we just plug in 0. What's the cosine of 0? Going to our unit circle, we're going to go to 0. Cosine tells us we look at the x or the y? The x value. So what's our x value? 1. So here we get 1/5 times 1, which would be 1/5. Perfect. Let's look at B. Does B work using substitution? Can we just plug in 0 right away? No, because it'll give us 0 in the denominator, which doesn't work. So we want to simplify. How could I simplify tangent? What does tangent equal? Y over x, but we're not evaluating it yet. We're not going straight towards the unit circle. So I want to simplify it in trig terms. So tangent would be sine over cosine. So sine of x over cosine of x over x. What do we do when we have a fraction in a fraction? Keep, change, flip. So keep the top, change to multiplication. We're going to flip our denominator to 1 over x. So now when I multiply these together, I have sine of x over x times the cosine of x. Do we notice anything that we could use here? We couldn't use substitution because when we plug in 0 into our x, we still get 0 in the denominator. But awesome. We know that sine of x over x equals 1. So I'm going to split this up. I'm going to say sine of x over x times 1 over cosine of x. So if I were to find my limit, as x approaches 0, of the sine of x over x, we get 1. Let's find the limit as x approaches 0 of 1 over cosine of x. We have 1 over cosine of 0. What's the cosine of 0? Going back to our unit circle. Cosine of 0 would be 1. Awesome. So we have 1 times 1 over 1, which would just be 1 times 1, which is 1. So we left off with example 3C. So here we have sine of 2x. This is called a double angle. We have double angle formulas. We can't combine sine of 2x with sine of x. So we want to use one of our double angle formulas and get rid of that 2x that we have there. So our double angle formula that we can use is 2 sine of x times cosine of x. So I'm going to replace the sine of 2x with 2 sine of x cosine of x. All right, so let's rewrite this. We have the limit as x approaches 0 of the 2 sine of x cosine of x minus sine of x over x cosine of x. So looking here, do you see any ways that we can simplify this? So I could take out, do we see a GCF on the top? Sine of x. So I'm going to take out that sine of x. We're left with 2 cosine of x minus 1 over x times cosine of x. See any other way we can simplify this? Sine of x over cosine of x is tangent, but it doesn't really help us because we still have the x in the denominator, which if we plugged in 0 into the x, that would give us undefined. Fabi. What is the limit of sine of x over x? 1. Awesome. So I want to split this up. I'm going to split it up with multiplication since everything's being multiplied here. Sine of x over x times 2 cosine of x minus 1 over cosine of x. So sine of x over x we know is 1. Now let's try direct substitution with the second part, now that I don't have an x on the bottom. If we plug in 0, we have 2 times the cosine of 0 minus 1 over the cosine of 0. Let's go to our unit circle. What is the cosine of 0? Cosine of 0 would be here. We look at the x value, which is 1. Awesome. So we have 1 times 2 times 1 minus 1 over 1. So cosine of 0 just turns into 1. 2 times 1 would be 2. Minus 1 is 1. And 1 over 1. And 1 times 1, 1. So our limit would be 1. So example 4b. What's the first thing we want to try? Let's try plugging it in. So let's see what the cosine of 2 pi over 3 is. So let's go to 2 pi over 3 on our unit circle. So that would be here. Cosine tells us we look at which value, the x or the y? The x. So what would cosine of 2 pi over 3 be? Negative 1/2. So example 4a, again we see that we have a 2x here. So it kind of tells us that we want to use our double angle. First thing we would do is try and use direct substitution, and that doesn't work. If you have a 2x that you're taking the trig function of, you're probably going to want to use your double angle. So I don't have a double angle formula for cotangent of 2x. Let's change this to be in terms of sine and cosine. What would I change cotangent to be? So cosine of 2x over sine of 2x over, since I'm changing everything to be in terms of sine and cosine, what would cosecant be? 1 over sine of x. Awesome. So now I want to change that sine of 2x to one of my double angle formulas. So sine of 2x, same thing we had on the last page. Sine of 2x would be 2 sine of x cosine of x. And then what would I do if I have a fraction and a fraction? Keep, change, flip. We're going to keep the top, change multiplication. We'll flip the bottom to sine of x over 1. See anything cancel? Sine of x's will cancel. So then we're left with cosine of 2x over 2 cosine of x. Now these don't cancel because cosine of 2x is not the same thing as cosine of x. But let's try direct substitution from here. Let's find our limit as x approaches 0. So if we plug in 0, we have the cosine of 2 times 0, which would just be the cosine of 0. And what's the cosine of 0? 1. Over 2 times the cosine of 0. What's the cosine of 0? 1. So 2 times 1 would be. So what would our limit be here? 1/2. Awesome. Our double angle formula is 2 sine of x cosine of x. So we're going to skip example 4C and example 5. Yes.